Now, I love building things, and I've shown quite a few projects on this channel, and sometimes I get requests to do special videos, and Goober890, also known as Goober88 the phonograph liker, has requested that I build a little gramophone or phonograph much like a little music box that they have. And this little music box, I'm not entirely sure how big it is. I'm going to put a picture on the screen if I haven't already of what I think it is, and it's about 12 centimeters or 5 inches square and maybe 20 centimeters or 8 inches tall according to the Amazon listing. Now, I wasn't sure I could build something quite that small, but I thought I'd give it a go. This is not going to be a tutorial, but I'm going to talk a bit about some of the issues, some of the design issues, and actually show the finished item and also it working, and also maybe a couple of stages in the middle showing how I've actually improved the design as I've gone along. Now, some parts of this are actually quite easy to do. I mean, the sound box and the horn for it, I'll just put on camera now. This is actually something that I've used before. Well, the sound box I've used in a previous video, but I have actually upgraded it so it takes standalone, separate gramophone needles. Previously, it was actually like this one here, where I just super glued a pin on, so I wasn't changing the needle every time. The horn you may recognize, or you may think you recognize. In fact, you will have seen maybe in one of my other videos this very similar but rather shorter horn. I have several of these horns actually. They're these air horn type things. They come in sets. I think they're designed to go on vehicles to play little tunes. I see them occasionally at car boot sales. Anyway, I bought some years ago. All I've done is sort of cut off the end there and just use a piece of 15mm, as it happens, pipe fitting there, which is standard UK pipe fitting, and attached it to this sound box. And let me know if you want to have a video on me building this sound box. I haven't really shown this in any detail, but I could do a video building this specific sound box or one very much like it if you're interested. So that's relatively simple. Now, the biggest issue actually was the motor. Now, the request was for a little phonograph with a crank handle on the side, or wind on the side. Now, obviously, I do own a few gramophone motors, so I'm going to put one on the table here. Now, this is actually a relatively small gramophone motor. But it's not that small for this project. If I get a ruler or a rule, you can see that it's about 4.5 inches or maybe 5 inches, 12 centimeters or so. And much the same in that, well, maybe 10 or so in that direction, and about 8 in this direction here. So it's pretty much the same size as the gramophone requested, or the build requested. But I could use this, but it's also, you know, arguably a bit of a cheat to use an off-the-shelf gramophone motor. So I looked around for other solutions. Now, I did have, or do have, this little clock mechanism here. This is much smaller. The key's actually there. If I find it winds like that. I looked at this and measured the speed that it's turning around here. Put a little bit of tape on it so you can see. So that's not really turning fast enough to play a record. I think it's even less than 33 1/3 RPM, so I didn't think I was going to get very far with that. There's also this little music box here. If I just wind that a bit too. I mean, it runs, but there's very little power in there, and the gearing is nothing like suitable for playing a record. So I didn't think that was going to be suitable either. Now, having shown that other gramophone motor, it's worth pointing out that there are actually quite small gramophone motors that have been made. This has got one, and it's actually quite difficult to see. I can see that there's a gramophone motor in there, and I'll put a little bit of video of me filming through the slats. But this little machine here is about the right size, and if I find the winding handle or the winding hole, this doesn't side wind, so, and it winds weirdly counterclockwise as well. But you know, it does work. It does run. And it has a little tone arm as well here. And in fact, it uses the brake, or uses the regulator, the speed regulator, I think, as the as the brake as well. So the lower this lever is down, the faster it goes, and then you can slow it down. And then you can stop it by pushing it all the way up. And that's actually quite similar to this motor here. Not sure if this is wound actually. Maybe let's put some winds on this just to demonstrate it. You can probably tell I'm doing this video live, so I have thought about what I'm going to say in what order, but I'm not doing it all heavily scripted or anything. So let's put the crank handle on. Let's give it a few winds. So you can see it spinning away there. Should be able to see the governor in there too. And as I adjust the speed control, with a bit of luck, you can see it presses against the governor plate or the rotating plate and actually stops it as well. So yes, so a gramophone motor can often be stopped by just pushing it down to the lowest speed, although they are also usually fitted with a separate brake on the platter as well, because you don't want to adjust the speed every time you play a record. So clockwork motors, not very practical. I did actually have a look on eBay to see if I could find a small clockwork motor, and I did find actually a motor suitable for one of my other machines, which I actually bought and demonstrated and fitted in a previous video. But I also, when looking through my collection of motors, also found some electric motors, and I didn't want to, and I don't want to build a machine that just runs off a battery or runs off a power supply. That's kind of a bit boring. But I did find these motors, and I thought, these have got gears on them, and I wonder if it's possible to actually use one as a generator to drive one of the other ones, because one of the things about certain types of DC motors is that they can be used as generators. Now that basically means that if you turn the shaft, you actually get electricity out of the wires. Now there's lots of information online about doing this. I've actually never done this before. This is not something I have any experience of at all. Another reason this is absolutely not a tutorial, but these motors, which are geared, and I think this one's rated at 65 RPM at 12 volts. Some of these are actually rated at different things, I think. Not sure about that one there. This one's rated at 60 RPM at 12 volts. So yeah, I thought that might work actually. So if I just actually connect a couple of these motors together, I'll demonstrate what I mean. Now these motors are second hand, and they're pretty worn out as well. But if I connect that to that, that to that, hopefully that's still in camera shot there. Maybe prop that up a bit. Now if I turn this, can we get it to actually turn? Right. Now you might see there the piece of paper on the shaft of the other motor is actually going around. Now it's not going around particularly reliably because, as I say, the motors are actually not in the best of conditions. But hopefully that demonstrates that by turning one motor, it's possible to get another motor to actually operate. And so if this actually had a crank on it, then potentially I could crank this motor around, and this motor here could drive a turntable. So that was my idea. So this is just like a little test rig. So I thought it's got to be worth a shot. Let's try that. Okay, so this is what I've built, and hopefully I've got it all in camera shot. But essentially here's the horn and the sound box as I previously described, and that goes on this bit here, which should be visible on one of the cameras. So that's the pivot there, like so. Oops, like so. And the actual turntable itself, we've got a motor here, which is the generator, which has got a little crank on it. This crank is made from an old pencil sharpener. You may know the sort. And it's just wired to another motor here, which actually drives the turntable. Now, just a quick note about gearing. As it happens, if the gearing on these two motors were the same, then I'd probably have to turn this motor at about 78 or more RPM in order to get this turntable to turn at 78 RPM. And these motors are only actually rated at 65 RPM, so that wouldn't really work. It might be suitable for playing 45s or 33 1/3 records. As it happens though, by sheer luck, this motor here is actually rated at 130 RPM. So for every turn of this motor here on the crank, I should expect to get 2 turns or so out of the motor driving the turntable. Now it almost certainly won't be quite like that, but the idea is that I should get away with turning this crank quite a lot less than 78 RPM in order to get 78 RPM out of the turntable. The turntable, I'm not sure if it's particularly clear on camera, but there's an old drill chuck under here, and this is the faceplate from a drill used for wood turning on a drill based lathe. And they've got a few other bits and pieces here just to hold the record on. So if I just turn this handle, you should see that the turntable actually turns. And I'm going to remove this piece of paper. I've got sort of rubber padding on the bottom here to help it stick to the table. So we'll just take that out. And I'm going to put a record on. Now I've got several records here. I've actually had a bit of bad luck trying to find a record that isn't copyright. These two seem okay, but I may have to I may have to reshoot this bit with a different record if I get any copyright issues. So I think this one is the one we're going to use. Now if you're hearing any background noise, it's because I'm filming this on a Sunday afternoon and there are people mowing their lawns and playing with balls and generally having fun outside. So hopefully not too much of that's coming through. Also, if you like this video, then please do give it a like so that I know and that so YouTube knows too. Thank you. So next thing to do is actually to put a needle on this thing here. This has got a needle chuck very similar to a proper sound box. I do need to use a little screwdriver though just to tighten it up. Okay, due to the broken bit on this record, I'm going to start in slightly. Ideally, I would get the record spinning before I lower the needle on. Okay, slight technical issue there. Hopefully I've got the second camera running again. So ideally I would have the record turning before I put the needle down, but it's not very practical for me to do that. I've got no way of doing that really. So I'm going to play this now. It doesn't sound that great, but bear with me because I have some improvements, or one really major improvement for this, which I will demonstrate shortly. But anyway, let's see what it's like just as it is. So that sounds pretty awful, and the reason being is there's just no regulation on how fast I wind the handle. Faster I wind it, the faster the turntable goes. And if I actually use this app on my phone here, this is RPM calculator or something similar to that. Let's line that up, and spin that around like that. You can see that it's not difficult to get it sort of in the area of about, you know, 78 RPM or so, but it's all over the place. It's jumping between 70 something and 80 something, and that just sounds awful really. Now back in the day, when gramophones or phonographs were first invented, hand wind machines like this, admittedly not with electric motors but with sort of direct drive, were quite common, and people did apparently manage to get them to play reasonably well, and I think with a bit of practice you could get them to sound or get the sort of speed okay, but I find the whole thing very unsatisfactory. So I thought, well, much like a real gramophone motor has a governor, maybe I can fit a governor to this too. So what I've done is I've actually connected up this unit here, in fact this motor here, to my bench power supply and worked out what the correct voltage is to run it at 78 RPM. And then what I've done is then created or put together this little circuit here, and this circuit regulates the power. So although if I put too little power in or too little voltage in it, it won't run at the right speed. If I put slightly too much in, it will actually cut it down or regulate it down to the correct amount of voltage to run at 78 RPM or thereabouts. So if I put this in the circuit, so if I unclip these connectors here. Now I'm trying to do this as live as possible rather than just setting up each shot and filming it and then doing the voiceover after, because you get more of a sort of view on the sort of problems that I get, and also from my point of view it's just so much quicker to do. Now it may or may not be obvious, but I've actually had to switch one of my cameras out because it just was not playing. So hopefully we won't have any continuity errors or any sort of issues. Anyway, that's in there now. Hopefully I've got that all the right way around. I have got diodes, protection diodes, to make sure that I don't accidentally connect it up incorrectly. Now, does that work? Yes. So on the face of it, no difference. But let's actually try the app again. Okay, so I'm going to try it with the app again. Now I've got the regulator in place. So you can see that, well, if I turn it slowly first, you can see that turning it slowly doesn't make it run at the right speed. And it's all over the place. So that's slow. I can speed it up and I can slow it down. But if I wind it faster till we get to about 78, 79 RPM, you can see it actually sticks around the sort of 78, 79 RPM. And that's because the regulator is actually limiting the voltage to the amount needed to go at that speed. So there's no point me winding like super fast, because I might exceed the rating of the gearbox on the motor, but also because any additional power is just thrown away as heat by the regulator. So anyway, that looks a lot more useful than what I had before. What I want to do is get some of the singing, because the singing is the bit where the speed variation shows up most. Well, that didn't sound too bad. I mean, there's a bit of distortion on the sound box. It's not a perfect sound box by a long shot, but the speed actually didn't sound too bad at all. there's quite a lot of motor noise, and you're probably picking up the motor noise because the microphone that I'm using to record this is actually pointed directly at my face. It's mounted directly above the turntable. You can't see it, but it's a sort of decent quality microphone up there, and it will be picking up quite a lot of the motor noise as well, probably. What I intend to do is actually mount a microphone sort of somewhere near the horn here, and actually do a bit of recording, so you can get more of the sort of sound quality that's coming out the horn rather than the overall sound of the mechanics of the machine. Okay, so I've got it set up with this additional fine microphone here. This is trying to pick up the sound directly from the horn. It's not the best microphone. It's connected by USB direct to my phone that you can see over here, and hopefully we should get a bit more of the record sound and a bit less of the motor sound, but we shall see. It's all quite close together. Okay, so what did you think? Let me know in the comments. And if you have enjoyed this video, then how about watching this one? Thanks, and see you in the next one.